Hello, good afternoon, everyone. I'm the co-director of the Center for Population Health Research, and Akademi Professor Olli Raitakari, who is the director, was unavailable today because of a PhD thesis defense, so he's the other main contact person regarding the Center for Population Health Research. So 3 years ago, a group of researchers, we realized that we have lots of these population human cohorts data around in the campus. And this is really like a bottom-up kind of an enterprise. We acknowledge that we have overarching shared research themes. Many of the cohorts have been focusing on non-communicable diseases with shared pathophysiological processes related to inflammatory processes, for instance, or stress regulation or metabolism. There were a bunch of prospective cohort studies with like follow-up times of several years, even decades, with lifespan view. So many of these cohorts actually hold several generations. And we have everything covered from pregnancy to aging. Some of the cohorts have interventions related to early nutrition and its impact on later cardiovascular disease, for example. And what is unique and common between all the cohorts is that we have collections of biological samples, clinical measurements, observational-based measurements, register linkages, and carefully characterized both exposures and outcomes. In addition to the diagnostic approach, so that we have, because most of these are general population based, so actually majority of the cohort participants may be healthy, at least for a long period of time during the follow-up. But of course, then there are people who fall ill, and then there is this diagnostic approach, which is possible. But we also have agnostic or dimensional approaches, which are unique to these population studies, as opposed to clinical studies, where people are selected based on a disease status, for example. So these pre-morbid intermediate phenotype pathophysiological processes are possible to analyze and investigate in these kinds of population cohorts. And we also have a translational research wing attached to this human data set, which works both ways. For instance, if a hypothesis is established by observing an association in an epidemiological study, so then this hypothesis testing can be taken further and examined in an experimental design. Or then like phenomena that we observe in basic research or in animal studies can be then tested in at least in association level in human cohort study. The main outcomes of interest that are shared and overlapping between the cohorts are listed here. They are, as you can see, they represent the major public health issues, major public health concerns that oftentimes share common pathophysiological pathways, and many of them are related to inflammatory processes or metabolic pathways, as you understand. And then there is also this psychiatric disease or neuropsychiatric disease focus, and also depression, for instance, shares the same pathophysiological pathway related to obesity, for instance, at least partially. So like a range of these endpoints is represented in these cohorts. And as I mentioned earlier, the antecedents and sort of the pre-morbid biomarkers or markers or indicators of these later disease risks are of high interest across the whole lifespan. And then also the resilience side, so who is not falling ill, is of high interest in these cohorts. These are the cohorts that are currently linked or affiliated with the center. Of course, we welcome others as time goes by. And the shared features are that these are long-term, prospective, general population-based cohorts with these selected domains of interest. But then there are like specific details or specific interests that are characteristic to a given cohort. For instance, the FinBrain is focusing on brain research, psychiatric outcomes. Then the STRIP study has these famous interventions of early intervention and their later life influences. And there are cohorts on reproductive health, etc. So it's both, we have things in common, but then there are these like specific things. And as a comment to this data managing thing, so what we have been doing now is that we have been harmonizing our metadata catalog. We sat down and realized that if a project has been going on for 40 years and another project has been going on for 20 years, it's really difficult to harmonize data afterwards. But what we can harmonize is the metadata catalog and information on what kinds of variables we have. And then another thing that we can harmonize is prospective data collection. So now that we are aware of each other's work and things that we are doing, so any new data collection will be done in harmony with the others. For instance, the FinBrain cohort is now collecting data on children that have turned 9 years, and we have a cardiovascular study attached to the cohort. So we use measures that have been used by the Young Pink study and the STRIP study for decades. So to ensure comparability and cross-cohort validation and like harmony between the cohorts in the future. And then I wanted to mention Noora Kotaja's lab because her lab is currently the most affiliated with these translational studies, with the affiliated with the Center for Population Health Research. But of course, there's lots of collaboration, domestic and international collaboration between the center and other like researchers and research groups. Just some numbers for you to get the idea of the scale of the work. So the youngest cohorts have been established in 2011, 2013, and the oldest 1980. The participants typically run in thousands, and if you think like of the number of follow-ups, which are usually numerous, and then there are thousands of participants, and the follow-up periods are in years or in decades. So the amount of data and the amount of collected biological samples is rather high. Some of the cohorts have started during pregnancy, others during infancy, and then the ones that are focusing on aging are collecting their data among the elderly population. This is like the big picture, how we see the possibilities and opportunities for using the cohort data in the context of, for instance, what was just presented by Riitta here and Juhani earlier. And so we have the longitudinal, multi-generational, multidimensional data set that has been collected from humans, from the general population. And then all these facilities are, I think, very easily and sort of flexibly linked, could be linked to reach the overall aim, which of course for us is to improve population health and to identify early biomarkers, early targets for prevention or early treatment modalities. And it's all very complicated, of course, but I think that the easy part is that the major public health issues, they really share common pathophysiological pathways. So it's not like everything should be studied in separate ways. You find something here, it inevitably helps another domain of public health problems. As these are human studies and medical studies, so the study participants enter the study by giving an informed consent. And this is binding. So they give a consent to specified research purpose. So this is not a biobank, but this is like something that they enter the study, they give this informed consent, they give a serum sample for specific purpose. The purposes can be very wide and the phrasing in the consents can be rather broad. but still it's something that should be acknowledged. This public interest clause in the GDPR gives us some flexibility. So for instance, if there is a serum sample that has been collected for 20 years ago, and then there is a new technology that enables analysis of something that could not be labeled or indicated in this consent form 20 years back. So then it's possible to run the analysis like within the framework of the GDPR, but still like the big picture and the main research purpose that the study subject has donated the sample for, that has to be kept in mind, and that's like binding. So the research collaboration would be the key and the main way to gain access to the data and like use the cohort data. And terms and conditions for data access or data transfer always need to be negotiated, but they can be negotiated. Like mere data sharing, like placing these cohort data sets to open repository or just donates data to a third party is typically not possible. But this research collaboration on its various forms is the way. Here's one example that comes from the InFLAMES study. So there is, for example, this one agreement between the InFLAMES study and Zora Biosciences. And they have this agreement that Zora Biosciences technology can be used to analyze serum samples for lipid biomarkers for cardiovascular disease risk. And then the research group runs the analysis, drafts the first version of the manuscript, receives the leftover samples so that the samples are back with the research group when the required amount is used. And then the business partner is actually co-authoring also the research paper. So it's research collaboration, but they can then use the results of the development of the results that are found in the research to develop their commercially available test for cardiovascular disease risk evaluation. So this is one practical example. Much more information can be found on our website. For contact details, it's me or Olli Raitakari, and the administration goes so that each cohort is still administered by the board or the PI of each individual cohort. So any negotiations for gaining access to a specific data set needs to go through the PI of each cohort. And we are run by external funding almost only. But the medical faculty has invested in shared office spaces to which we are moving next week. So then we actually become a real center in addition to being this network of population cohorts. Thank you.